I'm really happy to be here. I want to thank the organizers for the invitation. Today, we have a wide audience from different backgrounds. We have people engaged in R&D. We have people engaged in marketing. Now we have heard about a lot of insights from review experts. The VFB market is like in the darkest hours before we see a breakthrough. So I'm sure today's struggles will be necessary for a promising future in VFBs. Our company is called Wuhan Nanrui, and we have our VFB research arm under state power grid. As the society moves forward, demand for electricity will increase over time. And at our company, we have been working to study safety and efficiency on power grid. You can see we have a lot of projects involving renewables, including solar and wind. In developing solar and wind projects, we really value these. In one of the projects, we have won some honors and awards from the local government. As you can see, we really value safety. Safety is one of the top priorities in our practice, and our company is the only research unit under the banner of State Grid. In 2010, we started over 10 projects in energy storage. Currently, we have a very good lineup. Our main product is 32 kilowatt stacks, and we also have a lot of different modules at different levels of capacity. As you can see here, this project is at the Hankou railway station. And you could also see project, a container-based project for energy. We need to understand that better, and we need to talk about how the current situation is, and that is how we can better forecast the future. Clean energy is a necessity for our country's growth and for global development. We need to ensure during the transition from old energy to renewable energy, there could be enough technical support. Also, fuel will account for lion's share of the energy mix. Renewables will be on the rise. Energy storage should be one of the key pieces of the puzzle. And in our practice, actually, there could be different technologies involved, including field information system, data, and the cloud computing. Also, the IoT can be integrated into all this. As for the blockchain, we can even include the blockchain into the whole energy equation. Back in 2014, China proposed the concept of energy revolution. So for energy, why do we put energy together with population? Because we want to have a real transformation. And in September 2020, the government proposed an initiative. That initiative is known as 3060 initiative. That is, we need to achieve carbon peaking by 2030 and carbon neutrality by 2060. Yesterday, I saw a new story about carbon trading. Carbon trading will be better managed in the future. I'm sure electricity will flow more freely around the country. Maybe electricity generated in West China will be better transformed or transmitted to East China. And in that process, I'm sure energy storage has a place. In our understanding, the energy revolution has been picking up speed. And in that kind of landscape, we gotta ensure renewable energy play a bigger part in our process of achieving carbon peaking and carbon neutrality. Actually, we have the concept clean energy. Clean energy means clean energy has all the necessary supporting technologies, and carbon trading has become a mega trend. Also, the spot market for electricity has been developing quickly, and in Shandong province, this kind of market has been running. Market for a market for energy generated from clean sources. That market has been running in Guangdong smoothly. Over the past few years, we have seen huge investments in agriculture and also energy. A few years back, there was a green fund established for offshore uh, wind and solar. So I'm sure that is really inspiring and encouraging. Also, that spells opportunity for low carbon growth, and that also means a lot of momentum for VRFBs. VRFBs should not be considered as a silo. VRFBs should be integrated with the whole power grid. There should be a lot of response and collaboration between VRFB projects and power grids. We need to have, for example, peak shifting and frequency regulation. All those can be considered together with VRFBs, and all that means good news for the whole market of VRFBs. Carbon trading, which I just talked about, will be very useful for us to separate green electricity and carbon trading. I'm sure when the carbon trading market is mature, we can have a better decoupling between green electricity and carbon trading. Going forward, I'm sure more stakeholders can get involved. And in that landscape, energy storage will play a key part. A lot of diversified stakeholders can get involved in the electricity system, and energy storage will create more value. In the future, a lot of electricity consuming entities will get involved in the whole equation. Currently, as I mentioned, we are in a transition for energy. Traditional energy comes from sources, and this kind of old energy was very dirty, and the efficiency was also very low. Plus, there could be long-distance energy transmission. Efficiency could suffer. I'm sure there is going to be a new model where we care more about electricity quality and transmission efficiency. Also, we got to care more about peak shifting and load balancing. Going forward, distributed energy will continue to be one of the buzzwords. We will talk about how we can better improve energy consumption and energy production. We also will talk about how we can better integrate green energy systems into the smart city. In the future, the smart city will be really smart. The traditional model for organizing utilities for the smart city will be transformed. As you can see, infrastructure, transportation, industry 4.0, digital communities, all those be integrated as parts of the smart city. And in that smart city, I'm sure VRFBs can play a role in regulating and managing energy. So in the future, we have some clear rules for managing energy. For one thing, we gotta ensure we put in place green low carbon supply system of energy, and we also gotta further meetings and lower energy consumption in the city. Plus, safety really matters. We want to ensure we balance all the factors in developing new energy infrastructure, and also flexibility is a keyword. Flexibility means we can combine our new facilities better with existing infrastructure, and we need to ensure energy becomes another piece of the developing the smart city in the future. Electric vehicles have been booming here in China. I'm sure electric vehicles will be connected to our grid, and that could be, I mean, when those vehicles are connected in large numbers, there could be a huge impact on power grid. So how can we balance all the electricity users, and how we can better achieve energy collaboration? We need to create synergies in developing better energy systems. And energy storage is just like an electricity storage tank. With our smart management system, I'm sure we can use all the technologies to make a bigger difference.
So the previous physical structure could be broken, and also as energy storage players, we try to break the manufacturing way of thinking, and then it's a trend. So in the future, actually, in the overall power systems, in terms of the production, we will have a more new power system, and more cities will localize and prioritize the local renewable energy, especially talked in the 20th National Congress of CPC, such as to break and then to set up, which refers to the energy revolution and opening up new market in the future. Energy, IoT, and internet will be coupled, and for the high energy, high efficient conversion should be realized, and efficient utilization could be realized. So I'd like to summarize for the first part. I believe that the energy storage isn't a new energy, and Wuhan Nanrui started in 2010. So it has been 13 years. But actually, with the fourth energy and industrial revolution has been triggered, it has changed the supply and demand of the energy and the consumption structure. At the same time, the biggest one is energy, new energy plus energy storage. So it can play a bigger role, which is the electrocarbon attribute. Just like Professor Zhang Aifang said, then the lesson of the electrolyte, and with the hiking of the spiking of the vanadium, and it will have some limit about our usage. Therefore, energy storage under double carbon strategy, the market has fully opened. I'd like to also share with you the Wuhan Nanrui's effort in the application scenario. As we know that we have the Yunda smart chain and also electricity plus carbon trading mechanism. We serve as a stabilizer of the grid. So that is our understanding. And the second is that consumption of clean energy, reducing the carbon emission. At the same time, we will build the microgrid and participate in the demand management and load management. So why we put it into our comprehensive energy center? Because based on the understanding of the grid safety, energy storage provides the capacity reserve for urban power grid. And in the future, more and more low carbon and smart cities want to reduce enterprises' pressure in the carbon sink, and also to access to new energy more. So you could say we have some megawatts hour energy has been consumed at a high proportion. In the future, because the parks needs to invest and to attract enterprises with the green carbon needs, such as 1 ton of carbon in EU is just €100, and all the exported products must get a carbon footprint certification. And with such a certification in the park, we need storage, and we need to participate in the microgrid operation and give emergency supply. And now you can see this is smart park support by Wuhan Nanrui. And on one hand, we give the platform provision, and also all the electric devices are managed. And we have this micro grid environment, not just identify the patterns of energy consumption and operation, but also emissions and also green electricity. We track everything. And therefore, this is a market we need to follow in the future. The second is that for the concentrated harmonics and its threat about our grid, we can smooth things up. We can provide security for the grid. Therefore, in Han, next to the Hankou train station, we have 212 charging poles, and it's a charging tower. So actually, and the concentrated charging, there might be some transient shock risk to the grid. Therefore, if there is some risk, we need to consider the feedback of the grid. This is why we have this vanadium battery. It has been put into operation, and it is just a platform for the grid. So as a subunit, it has participated, and we have dispatching towards the last level. And upon the design, and the owner didn't imagine what kind of function should be offered by vanadium, but at the feasibility, actually the concentrated charging has a high risk about the grid. The grid cannot really take all the risk of concentrated charging. Last year in Sichuan province, it had a drought, which is unseen in the century, and the hydropower was depleted, but Hubei province undertook the ultra-high voltage supply of power. State grid spent a lot of time and energy to buy the demand, and actually this is a very good way to apply the functions. This one as well, as I know, in the downtown area, this is the first project in a commercial way. And the first scale is not very big, 100, 200 kilowatts in a container, but in actual application, it could react with a major grade, so it's very meaningful. And in addition, I'd like to further talk to you about the PV, and also the wind investment is very heated, and the tariff is getting lower and lower, and the investment is high. Therefore, in some of the regions, and for some scenarios, actually, we can find a good position, such as in the rural revitalization. So we can support the rural grids, especially in some areas, the terminal voltage is very low, and the line is very long. Therefore, sometimes there is over voltage tripping, overload tripping, and also there's a big difference between the valley and the peak. Therefore, we can put our small energy storage cabinet there with a promising future. In the past, we said that the vanadium battery counted a big area, but actually only Beijing, Shanghai, and Guangzhou maybe are very sensitive about the coverage. So this is my personal understanding. The first is that actually the value is very high, especially to offer the adjustment resources for the system, and the usage is the key. The second is that my understanding is that it's not a power bank. Power bank is that once you insert it, you can just charge, but storage means that you need to exchange and interact with the grid, and you need dispatching and scheduling and command from the grid. And therefore, it's a safe and long-term and a big capacity, and that is a big evaluation standard about the storage. Therefore, in the future, it has a promising and imaginative future, because the feature of a vanadium battery is a safe and large capacity and long-term, and electromechanical many response capability is very high, and also it can give very good support to the grid in terms of inertia. Therefore, those are some reflections of Nanrui for many years, and thank you for your comments. Thank you, Madam Zhang. You address us from the great end, and you depicted a beautiful vision for us. And any questions? Thank you, Madam Zhang. That is a very good talk. Yes, storage could play a very big role, and that is disruptive. My question is, So no matter it's a vanadium or other battery, how about the price? 1 kilowatt hour capacity. So how much is regarded as reasonable by the grid? Yes, thank you. The price. Well, actually, Nanrui has been working on the vanadium battery for 13 years, and our stereotype is that the OC premium is based on the value. And I'd like to talk about the price range of vanadium. How can we tell what is the appropriate price, and how can we make the price acceptable by the market logic? And first is pumped energy storage. Actually, it didn't went well. It didn't go well during the 13th five-year plan, but due to the mechanical storage, it has a complete system without a bottleneck. Therefore, maintenance went on well. Therefore, in 2021, which means after the double carbon, it was truly investable. So for the pumped energy storage, the capacity refers to the 5-year age national bond or treasury bond, and for the price of the electricity, it's involved in competition. So the core is then for the vanadium technological route. What kind of role can it play? So is it needed? If the vanadium battery technical route is needed, you can have some negotiation. And if I tell the grid, it's a option, but actually the said that what I need is a stable, safe, long distance, and a large capacity, and interactive friendly. But I tell them that the cost is very high. Material cost is very high, but what about the operation and the maintenance of the vanadium? Actually, yes, I can say that we need to follow the of pumped energy storage, because pumped water storage, water pumped storage has been completed over the 13th five-year plan. So we need to follow its path in the 14th five-year plan. Its planning and its route has been completed. It has a very completed planning. Its supporting role about the grid is very good. So I didn't answer your question directly because I'm not very I don't want to directly answer this question because I didn't really. It's like a hunting game. You don't really hunt the game, but you're thinking about getting the share. And vanadium price gets very, very high. Manufacturers would just do nothing because we cannot share the R&D investment throughout the decade. But when we use it, ultimately, the main benefit and main returns will be taken away by some other links. Therefore, if we have some benign development of the 14th five-year plan, we can refer to we can have the price model such as a pumped energy storage, like a volume price rate plus the electricity price rate. The combination is not something we can calculate. It is derived from the market. The market cannot be set by the manufacturer. The price is confirmed by the average labor time, work time of the society. So it's derived from the market. So any other questions? So any questions on the internet, on Zoom? We have another question back there. Hello, Madam Zhang. My question isn't because I have seen your slides, you talk about the rural way, multi-village storage way of storage. Yeah, I'm quite interested about that because currently we have found that vanadium storage is usually a very centralized mass or big size storage. But personally, I think that in our industry, they're just concentrated in some top players. But when you talk about a rural application, multiple village to have one vanadium storage system, and in that way we can make it popularized throughout China. It is quite in line with some national policies, such as the rural and urban linkage or stuff like that. But for such kind of application, Madam Zhang, you just mentioned one aspect, but as for the overall industry, I seldom heard such kind of information. So my question goes like, what is the specific timeline for this? rural application for storage. Actually, for any commodity, we need to have a value, and actually the value of the storage is just like what I was saying. I have shown rural is one of the scenario, but this country is talking about prosperity and revitalization, especially technology in the countryside. The premise is electrification in the countryside. We have a lot of electrified devices setting up in the country. In the past, the country rural grid had a little capacity. We just ensure the supply, such as we had some, needs addressing to the country's need. But now, as the capital is penetrating to the countryside with a lot of PV and wind power, with local access to the low voltage rural areas, but it will cause some risk towards the overall rate. Once we have a problem, we have a demand, right? Therefore, in the rural market, we have a very big proportion of PV and low cost energy and a lot of new needs. Therefore, the vanadium battery will have its own share. So we won't need to discuss about a centralized or not centralized storage, but whatever. But we need to see that whether what is the functional value.
We gotta be clear why we need this. Do we need to do some peak shifting? Do we need to have some different pricing mechanisms for different times of the day? Or do we need to have better coordination between different levels of the power system? Anyway, in the countryside, I could see a lot of demand. In the countryside, the share, PV and wind could account for a large proportion, and there could be a very good scenario. We need to set up a comprehensive energy center for the countryside. Actually, we have done a lot of projects for smart industrial parks. Like in Wangang, we have built a smart campus, and also in Shanghai, we have built a smart campus for Shanghai Jiaotong University, and that is our thinking. Comprehensive energy management